calendar one more time here for those that are watching the video at home. Again, test is next block day, because next Tuesday is ACT, and so I don't see 1 through 4, and 5, 6, and 7 are short. So we'll test on Wednesday, Thursday of next week. Today's the last day of new stuff. So there's only been three lessons in this unit. Sum and difference. We'll give you those formulas. Doubles, we won't give you those, but you can get them from the sum and difference if you want to. And then today we'll do half angles, and we'll give you those. So sum and difference, or excuse me, doubles are the only ones that are not given on the test. We'll give you all the others. All right, so notes page, notes 3, half angle identities. Half angle identities are not as useful in calculus as the double angle identities, but we teach them in pre-cal because really it's just more practice on working with algebra and pre-cal and angles, and it's just a good combination of things. So here's the formula for the half angle identities, and again, these will be given to you. In fact, I printed the test formula sheet yesterday. Sine of 1/2 x plus or minus square root 1 minus cosine x over 2. Plus or minus square root 1 minus cosine x over 2. Cosine of 1/2 x plus or minus square root 1 plus cosine x over 2. So the big difference there is the minus and the plus in the middle, otherwise they're the same. Tangent is actually easier. It's like the only place in the world where tangent is easier than sine or cosine. 1 minus cosine x over sine of x. Why we save these for the end and what makes them harder than the others is this plus or minus thing. Can you think of another place in math where there was a plus or minus the square root? Where did that happen? Yeah, the quadratic formula. And in the quadratic formula, you get two answers. You get the plus answer and the minus answer. This is different than that because it's not both. You have to pick plus or minus, not both. So in the quadratic formula, it is both. You get two solutions. That's, then x squared leads to two solutions. But the sine of an angle, there should only be one sign. It should either be positive or negative. So you have to figure out which one it is. So be careful. The plus or minus out front, let that remind you to pick one. But don't leave it as both, because it's not both. You got to pick one, and that picking is maybe the hardest part, because we give you the formula, you know how to draw the pictures, you just plug things in. So you got to be able to pick whether it's the positive or the negative, and that's Roman numeral 3, finding the sine of 1/2 x and cosine of 1/2 x. The tricky part. I don't know that it's tricky, but it's the important part of those identities is finding the correct sign. Again, it's not plus and minus, it's plus or minus. If x is in quadrant 1, then in which quadrant does x over 2 lie? Well, quadrant 1 means that x is between 0 and pi over 2. Right, that's what quadrant 1 means. Somewhere in there. If I want to know where x over 2 is, well, I can multiply this whole thing by a half, and I get 0 is less than x over 2 is less than pi over 4. So if x is in the first quadrant, x over 2 is even narrower, between 0 and pi over 4, but that's still the first quadrant. Right? If you take something that's in the first quadrant and you cut it in half, you're still going to be in the first quadrant. Oh, and I guess while we're here, all trig functions are positive in the first quadrant, so we like when that happens. All right, if x is in quadrant 2, well, this is how we'll figure out whether it's positive or negative. So this is just finding the plus or minus part. So if x is in quadrant 1, x over 2 is in quadrant 1, and our answer will be positive. We don't have to worry about it. If x is in quadrant 2, that means x is between pi over 2 and pi. And we'll do the same thing. If we want to know where x over 2 is, then let's multiply it all by 2 or divide it all by a half. So let's see, pi over 2 times 1/2 is pi over 4. Oops. Pi over 4 is less than x over 2 is less than pi over 2. So that means our x over 2 is between pi over 4 and pi over 2. So that's also in quadrant 1. So if the original angle is in quadrant 2 and we divide that by 2, we land in quadrant 1. And again, everything's positive in quadrant 1, so we like that too. If x is in quadrant 3, so that would mean x is between pi and 3 pi over 2. Same process, multiply by a half to figure out where x over 2 is. Pi over 2 is less than x over 2 is less than 3 pi over 4. So let's think about where that is. Pi over 2 and 3 pi over 4, so somewhere in there. So that's quadrant 2. Sine is positive in quadrant 2. Cosine would be negative. Lastly, quadrant 4, so 3 pi over 2, 2 pi. We want to know where x over 2 lies. Multiply by a half. So 3 pi over 4 is less than x over 2 is less than pi. Between 3 pi over 4 and pi, be right there, that's also quadrant 2. So divide the original range by 2 to come up with the new range. Now there's an even better trick to that. Maybe you can figure it out if we kind of look at, if x is in quadrant 1, then x over 2 is in quadrant 1. If x is in quadrant 2, x over 2 is in quadrant 1. So I'm just summarizing the 4 things we just did. If x is in quadrant 3, then x over 2 is in quadrant 2. And if x is in quadrant 4, then x over 2 is in quadrant 2. Here's your shortcut. Instead of thinking about drawing quadrants and writing all that stuff out, just divide the quadrant, or the quadrant number, by 2. And occasionally you have to round, but you know how to round, so no big deal there. So 1 divided by 2 is a half, but that rounds to 1. 2 divided by 2 is 1. 3 divided by 2 is 1.5, which is 2. 4 divided by 2 is 2. So we went through all this, but you really don't have to do all that. Just divide the quadrant by 2 and round the right way. Round as you're supposed to round. So all that was to determine the sign of your answer. After you do that, then you just use the identity, and it's kind of like all the other ones. Like draw the picture, plug things in, be careful with your algebra, all the usual things. So the only extra thing today is make sure you grab the right sign, the right plus or minus. So some examples. Given that sine of x equals negative 12/13, and x is between pi and 3 pi over 2. Okay, so before we go any further, what do you think we should do with that information? What have we usually done with that information?
We should see what quadrant.
Okay, you should see what quadrant it's in. So it's between pi and 3 pi over 2. So that would be quadrant 3. What do you want to do next? So x is in quadrant 3. Okay, you can divide it by a half. So that means if x is in quadrant 3, then x over 2 is in quadrant
2.
Yeah, 1.5, but that doesn't really make sense. Quadrant 2. So all of that's good stuff, but there's still one thing we should have done at the very beginning. How do I figure out what this thing looks like? It's the same thing we did Monday and Tuesday. It's been too long. It's easier than all of those things you're trying to throw out there. JD, what's this? I think you're on the right track. Just draw the picture. Draw the picture. What quadrant do I want to draw the picture in?
Quadrant 2.
X is between pi and 3 pi over 2. So I want to draw it where it tells me to draw it. So we kind of jumped ahead here. And when we divide it by 2, it lands in quadrant 2, but that's not the picture I'm drawing. I'm drawing the picture of the original. So it's probably best to draw the picture first and then worry about where the other quadrant is, or the new quadrant is. So this is my picture for x. Let's see, sine is opposite over hypotenuse. So negative 12 over 13. Missing side is 5. Oh, it is a negative 5. I'm not awake this morning. Thank you. Good call. You guys already know that's probably the most missed part of all these problems is being asleep and missing the negative. All right, so sine of x over 2. I'm going to just write the formula. It's plus or minus square root 1 minus cosine of x all over 2. Now we already said that x over 2 is in quadrant 2. Sine is positive in the second quadrant, so I know it's going to be the positive answer. All right, cosine of that angle would be negative 5/13. All right, here comes the fun part. No, because I wanted an exact answer. The question was, do I plug that in the calculator? The calculator would give you a decimal, but I want an exact answer. So I want an answer in terms of the square root. Let's see here. The pre-cal part of our problem is over. Now it's algebra. I don't like fractions and fractions. So let's multiply top and bottom by 13. That'll fix that that fraction down there. So distribute the 13. 13 plus, the two negatives make a plus. On the second fraction, the 13's cancel. And in the bottom, 13 times 2 is 26. And by the way, this is still under the big square root there. So square root of 18 over 26. Ugh. What do you want to do next? Yeah, let's reduce the fraction before we worry about the square root. So that would be 9 and 13. Oh, that's good news. Why is that good news? Because it's 3. So 3 over square root of 13, and then 3 root 13 over 13. So these are just a blast because you got to pick the sign, and then you got to be careful with fractions and square roots and fixing. Part B, cosine of x over 2. So I've already got my picture. I know I'm in quadrant 2, or x over 2 is in quadrant 2 anyway. And if x over 2 is in quadrant 2, what's the cosine? Positive or negative? In quadrant 2. Negative. So I'll use the negative 1. 1 plus cosine of x all over 2. Careful, that square root goes to the top and the bottom. So negative 1 plus negative 5/13 all over 2. Why don't you see if you can take that one from there? It's the same path. Different answer, obviously, but same path. Multiply by 13 and see if you can go from there. So, yeah, it's a lot of steps. Multiply by 13. 13 minus 5 is 8. 8 and 26 reduce. Square root of 4 is 2. And then fix the square root in the bottom. Be careful. Like, you know how to do all of those steps, but it's like 4 or 5 little steps where errors are lurking. Tangent, 1 minus cosine x over sine of x. So I don't have to worry about simplifying square roots. I don't have to worry about picking a sign, a plus or minus. So again, once in a while, probably this is the only place where the tangent formula is easier than the sine and cosine formula. So 1 minus negative 5/13 over negative 12/13. So let's clear the 13s. So that would be 13 plus 5 over negative 12. 18 over negative 12. It's negative 3/2. And we didn't do it this way, but we could have. We could have just done sine over cosine. And that's a lot of stuff going on, but keep it, change it, flip it, a whole bunch of stuff cancels, and we'd have been left with negative 3/2. So I feel good about that answer, because I used the formula, but I could have just done sine over cosine and got the same thing.
Can you explain going from on cosine from negative square root of 4 over 13 to simplifying it down there?
From here to here?
Yeah, I need to do it.
Okay. You're going to be kind of disappointed or
Probably will.
when you hear the answer. you can split up the square root as square root of 4 over square root of 13, like that. And then what's the square root of 4? 2. Let's skip number 2 because it's the same thing as number 1 and number 3, although somehow that one got labeled number 8. Secant of x equals 3/2 and x is not in quadrant 1. Okay, let's draw this one first. Secant of x is 3/2. Secant goes with cosine. So h over a is 3/2. But not in quadrant 1. So where am I supposed to draw this thing? Where is the secant positive? Yeah, secant's positive in 1 and 4, but not quadrant 1, so we're in quadrant 4. So another one of those tricky questions. So hypotenuse is 3, adjacent is 2. Opposite's going to be negative, you know that much. I missed it once today, I'm not going to miss it twice.
5.
Close, I think. 2 squared plus b squared equals 3 squared.
3 square root of 5? Wait.
So 9 minus 4 is 5.
Oh, square root of 5.
Square root of 5. And 5 didn't look right because the hypotenuse is supposed to be the longest side, so square root of 5.
I was trying to do it okay.
Okay, sine of x over 2 is plus or minus big square root 1 minus cosine of x over 2. Let's pick the plus or minus thing here. So x is in quadrant 4, which means that x over 2 is in quadrant 2. So in quadrant 2, x over 2 is in quadrant 2. The sine will be positive, and the cosine will be negative. So I'm going to just jump ahead to part B here. Go ahead and put my negative out there. Square root 1 minus cosine of my picture is 2/3 all over 2. So I'm going to keep working them the same way. I'm going to multiply by 3 over 3. So 3 minus 2 over 6 will be 1/6. Again, maybe I should show this step of breaking it up like that. Some of you are jumping to the answer already, I hope. Square root of 6 over 6. Cosine of x over 2. Big square root 1 plus cosine of x all over 2. I already picked out the negative, so that I know my answer is going to be negative. Let's see, cosine is 2/3. Yeah, cosine was always been 2/3 for this problem. So multiply by 3 to clear the fractions. 3 plus 2 over 6. Five, 6. Uh-oh. I've made a small mistake. Multiply top and bottom by square root of 6. So square root of 30 over 6. Why is that not right? What did I do wrong? It's a fairly common mistake. I think I would have caught it if I was working this, but
Then the negative needs to be up front.
yeah, I left off the negative. I got focused on fixing the inside, and I forgot about that negative needs to be there the whole way through. Tangent, 1 minus cosine over sine. I don't have to worry about any square roots or picking the plus or the minus. 1 minus 2/3 over negative root 5 over 3. Well, that doesn't look great. Multiply by the 3's to at least clear those out. So 3 minus 2 over negative square root of 5. So 1 over negative square root of 5. And with just enough space left, negative root 5 over 5. Draw the picture, pick the quadrant, apply the formula. The same stuff we've been doing. So I think that puts us on to worksheet 4 because, yes, worksheet 4. Because we spent 2 days on the sum and difference. Thank goodness the first 5 are just pretty straightforward. So try those over the weekend. On Monday we will review. So that might mean you want to look at worksheet 5 as well. Officially that's Monday's assignment, but for you guys especially, I won't see you Tuesday. So Monday will be our last review day before the test. So we'll review on Monday, but that might mean you want to peek ahead at worksheet 5 and try some of those.